Tangents of polynomials. We're asked to write an equation of a line tangent to this graph at the point where x equals 2. All right, so we need a line, a tangent line. So I would start off with what's the equation of a line. The equation of a line is y equals mx plus b. All right, and our parameters, or the numbers we're looking for, are m and b. Y and x are inputs and outputs. So we need a slope and we need a y-intercept. Or you can think of it about it as if we have a slope and a point, we can find the y-intercept. Remember, there's also y minus y1 equals m times x minus x1. And then we would usually convert it into this form. This is our point slope form. So either way, if you have a slope and a y-intercept, you're instantly there. If you have a slope and a point, then we can do that and manipulate it to find our equation of a line. So let's go ahead and find the point first. They want it at x equals 2. So we need the y. So we have x equals 2, but what's our y value? Okay, so this is our y value that goes with 2. So we just go ahead and plug 2 in here first. So I'm going to get g sub 2 is equal to 2 cubed minus 6 times 2. 2, 4, 8 minus 12 equals negative 4. So I got negative 4 as my point where this tangent line is touching the graph at. So it's the only place, well, it could be ups and downs and stuff and touch it otherwise, but that's our focus. That's the slope that we want. So the next thing we need is slope. How do we find slope? Derivative. Derivative gives us the instantaneous slope at any point. So we need to find the derivative now. So we'd say g prime of x is equal to, and we apply our derivative to each term. So that would be 3x to the 3 minus 1 minus 6, and that's times 1. So remember, there's like a little 1 right here. So 6 times 1, x to the 1 minus 1. From pretty soon, I'm going to stop showing my work here. We can start always just dropping the x as the coefficient of it when you just have x to the first power. So g prime of x is equal to 3x squared minus 6. Okay, so I just went ahead and dropped it, and I showed it in the last video how I did that. Now, to find the slope at this point, we plug in the input that we're looking at. So that would be g prime of 2 is the input. We're looking at x equals 2 to find the slope. So that means 3 times 2 squared minus 6. 3 times 4 minus 6 is 12 minus 6 equals 6. So that's our slope. G prime of 2 is equal to 6. So our slope at 2 is 6. Our m is 6, and our point we're looking at is 2 comma negative 4. Now there's two ways of doing it. You can use the point slope formula, or you can plug everything into the y equals mx plus b formula to find b. I'm going to go ahead and do that option. So this is my x, this is my y, and I get negative 4 equals our slope is 6, our x is 2, plus, and I'm looking for b, what that answer is. Negative 4 equals 12 plus b minus 12 minus 12, and I get negative 16 equals b. Last step, rewrite it as an answer. So therefore, more advanced math, we start using 3 dots to say therefore. Therefore, y equals, I'm giving you what you asked for, m is 6, x, b is negative 16. y equals 6x minus 16. Nice work. Got it. Okay, so this looks like exactly the same steps. I would find the point first, so I'd plug 4 into here to find the output that's associated with 4. Once you have your point, then you need to find the slope at this point. So you take the derivative. Once you have the derivative, you plug in 4 to find the slope at that point, and then you have the point slope formula option or the y equals mx plus b option to find it, and then see which one matches.